Hi, I'm Carlene.
Hi, I'm Leah.
And we went around our community with a focus on to help us answer some questions on advanced tree diagrams. Here's the questions we asked and a sample answer.
Do they bark like a delivery man?
One of them barks, the extra small one, but the other two are calm. Ellie, what's your name?
My name is Rich.
And what's your dog's name?
Mac.
And would you say your dog usually barks at delivery people?
Sometimes he barks at me.
Okay, but usually.
Yeah, usually.
Melly.
And what are your dog's names?
This is Aspen, and this is Hendrix.
Do they usually bark at delivery people?
This not her.
Okay.
What size are they, would you say?
Well, my golden retriever is like kind of big, so I would say like large, but my like German Shepherd mix is like on like the smaller medium size.
What's your name?
Brian.
And what's your dog's name?
Odin.
Okay, would you call your dog small, medium, or large?
Medium.
What's your name?
Journey.
And what's your dog's name?
Carrie.
Would you call your dog small, medium, or large?
She's small.
Now let's apply all the info we gathered into a word problem. When surveying about dogs in Pinellas County, 47% were medium-sized dogs and 21% were small. Of the medium-sized dogs, 45% barks at the mailman, while of the small and large dogs, 50% and 67% respectively barks at the mailman. Suppose we choose a dog from the study at random. A. Draw a tree diagram to model this random process. B. Given that a dog barks at the mailman, what's the probability it was small? C. Find the probability that a dog was large or doesn't bark at the mailman. Starting with part A, step 1 is to identify the events and their probabilities. Where the first event is in relation to size, 47% were medium size and 21% were small. The second event is barking at the mailman, with 45% of medium barking, 50% for small, large 67%. From this data, we now know that we need to find the percentage of large dogs and how much they don't bark at the mailman. Step 2 is to draw the initial branches representing the first event, which we know as small, medium, and large. Step 3 is to fill in the given probabilities and find the remainder by adding the given and to subtract that from 1. Where we were given 0.21 were small and 0.47 were medium, we add them together and then subtract from 1, getting us 0.32 for large dogs in Pinellas County. Step 4 is to further divide each branch by the second event, which is whether they bark or don't. For step 5, we repeat what we did in step 3, but now each section equals 1. So for the small section, 1 minus 0.5 will equal 0.5. Medium, the 1 minus 0.45 will equal 0.55. And then the large, which we do the same, will equal 0.23. Step 6 is to multiply the probabilities down each branch and state the answer. So for the small section, 0.21, and then times the percentage they bark, which is 0.5 equals 0.105. Of course, the don't is the same. And then for medium, barking is 0.45 times 0.47 equals 0.2115. And then you can repeat, and that'll get us 0.2585, 0.2144, and 0.1056 for the remaining 3. And all of these, when you add them, should equal 1, and if not, you did something wrong. Now onto part B. This is a given problem and is solved with the formula P and in parentheses A/B. Where the slash given, the formula is read as the probability of A given that B occurred. So the words following given becomes the denominator, which you find by adding the related probabilities. So in this case, meaning we add all the probabilities of dogs barking, so 0.105 plus 0.2115 plus 0.2144. And then the numerator is one of those values of the denominator that fulfills the requirements, so small and barking, leading us to 0.105. So that our answer is 0.105 over 0.5309, or 0.1978. Finally, for part C, this is an OR problem in which you add the probability of event A with event B, which is large and doesn't bark. However, for OR problems, if the events are not mutually exclusive, meaning that they don't overlap, then you have to subtract the probability of the two happening from the sum. So in this case, the event of not barking and large overlap, so we had to subtract at the end. So now we add all the probabilities of a large dog plus the probabilities that they don't bark minus the overlap, which is 0.1056, resulting in 0.835 as our answer. And that's how you solve advanced tree diagrams. And you can test out what you learned here in this problem on the screen now.